Hello my dear students. In the last class we have learnt about the basic terminology related to measurement system. Now in the today's class we will try to understand what is statistical analysis in the measurement system. Before we start our topic, let me recall our class number 5. In that, the last topic which I have explained, that is random error. As you know that the random error is also called as a residual error. These errors remains in the measurement system even after the removal of systematic error, so that these errors are not obvious and it is very difficult to figure out in the measurement system. So now, to find these kind of error, we need to perform some mathematical calculation, or we need to do mathematical analysis of the data in the measurement system, so that the mathematical analysis of a data in the measurement system is called as statistical analysis. Here, the statistical analysis of data is important because it allows an analytical determination of the uncertainty of the final test result. In the statistical analysis, there are some terms we need to understand. Those terms are: first one, arithmetic mean. Next one is a deviation from the mean. Then average deviation. Next one is standard deviation. Then variance. And the last one is probable error. It's very important to know what are these terms and how these terms are very helpful in the mathematical calculation. Let us try to understand one by one. First one is arithmetic mean. Here, arithmetic mean can be defined as it is most probable value of the measured variable, or it is also called as average value of all the readings. So in the measurement system, arithmetic mean is denoted as x bar, and the expression for arithmetic mean is given by: consider the experimenter has taken n group of readings, and each readings are represented as x1, x2, x3 up to xn, so that here arithmetic mean can be calculated as the summation of all the set of readings taken, and it is divided by the total number of reading. That means x bar is equal to x1 plus x2 plus x3 plus x4 plus up to xn, divided by n. So that the above expression can be written as x bar is equal to summation xn, where n is varying from 1 to n, divided by n. Here x bar is equal to arithmetic mean. x1, x2, x3 up to xn is called readings taken or measured value, and small n indicates total number of readings in the measurement system. By using this expression, we can find the average value of all the readings in any problem. For example, suppose 4 measurements were recorded when measuring a voltage by using voltmeter, such as 41.7 volts, 42.0 volts, 41.8 volts and 42.1 volts. So that here arithmetic mean can be calculated as, first we know that here total number of reading, that is small n, is equal to 4, and the number of readings taken or the value which we have measured by using voltmeter is first reading x1 is equal to 41.7 volt, second reading, that is x2, is equal to 42.0 volts, then x3 is equal to 41.8 volts, and last reading, that is x4, is equal to 41.1 volts. So that arithmetic mean is x bar is equal to x1 plus x2 plus x3 plus x4 divided by n. I hope you all understood that why I have written this equation, because in the given problem total number of reading is taken are 4, so that the equation for arithmetic mean becomes x bar is equal to summation xn, where n is equal to 4, so that here n is varying from 1 to 4, divided by n. So that substitute the value which we have measured in the above equation, we will get the expression as this. Now, after calculating this expression by using your calculator, you will get the answer as 41.9 volts. That means here the average value of the given problem or the arithmetic mean x bar is equal to 41.9 volts. This is how we can find the value of arithmetic mean in the measurement system. Next term related to statistical analysis, that is deviation from the mean. Deviation from the mean is denoted as dn, and it is defined as it is the departure of a given reading or observed reading from the arithmetic mean value of the group of reading. So that deviation from the mean can be expressed as dn is equal to xn minus x bar. Here dn is equal to deviation from the mean, and where xn is equal to readings taken in measurement. Similarly, x bar is equal to arithmetic mean in the measurement system. Suppose in the measurement, readings taken or observed reading as x1, x2, x3 up to xn, so that the deviation of the first reading xn becomes d1 and the deviation of second reading becomes d2. Similarly, the deviation of the third reading x3 becomes d3 and so on, so that the deviation of first reading d1 becomes x1 minus x bar. Similarly, d2 becomes x2 minus x bar and d3 becomes x3 minus x bar. Here note that the deviation from the mean may have positive or negative value and that the algebraic sum of all the deviations must be 0. In the next class, we will try to solve some of the problems related to deviation from the mean. This is what end of the presentation. Thank you and see you in the next video.